Introducing Ben Dechrai
Perfect.
with privacy, security, and convenience.
Thank you. Hello, everyone. Have you tried the veal? Who's got a carb coma? Oh. Well, that's probably good. I don't need to do any interpretive dance today. No. I do have hecklers in the front row. Please make them welcome. All right, so yeah, my name's Ben Dechrai. I want to talk to you today about work in progress that I'm going through at home to try and make sure that my home automation is secure, private, and still convenient. For me, convenience is most important, because if I can make my home automation convenient, my wife won't kill me. Hands up who's done any kind of home automation already at home in some kind of way. Hands up who's got a partner or other household member who's not technical. There's a lot of overlap there. Keep your hands up if that does not cause you any concern. Only 1, 2 people. Excellent. I'd like to know your tricks. Ah, yes, that is the other option. Same for you? Ah, perfect. Yeah, well, it doesn't necessarily work for me, but I was talking to somebody before this talk, and they were asking whether I was going to go into VLANs and stuff, and yes, we will have a look at the different ways you can secure your home network as well. And I'm one of these self-professed tinfoil hat wearers. I have, on occasion, spoken to people about the viability of subdermally implanting tinfoil. Apparently, the aluminium brain-blood barrier thing is an issue. I'm going to wait for science to tell me it's okay before I do that. But I do over-engineer things for my security and my privacy, to the point that I actually disable myself from doing a lot of things. I'm hoping there's at least 1 or 2 people in the audience who feel that way as well, mostly just to validate me. And I want to talk to you about the journey that I've gone through to try and make my home as secure as possible. I try and roll a lot of the things myself, but I also have off-the-shelf products that I want to make work as well. Before I get into that, if there's any words there in that word cloud that resonate with you, some of them are, ironically enough, possibly not ironically at all, related to this talk. But if there's anything in that word cloud that interests you, come and have a chat with me at any point during the conference, and we can basically rant at each other. That'll be a lot of fun. My name's Ben Dechrai. You can find me on that. I don't know whether I've broken any trademarks, but that Instagram logo there. Insta-twits. I also have a YouTube channel. I have my own URL shortener because I don't have enough followers yet for my own YouTube URL. I'm at 81. I feel very proud of that. So if there are 19 people in the thank you. If there are 19 people in the room who want to follow me on YouTube, I can get my own URL. And if you're listening at home, you can do it too. I've also got a website which keeps changing and probably doesn't have any useful information on it for you at all at the moment. I work for Auth0 as a developer advocate, but my talk here today isn't about Auth0. If you haven't heard of Auth0, we do like OAuth identity in the cloud type products. Come chat to me afterwards if that's something that sounds interesting to you. So, securing the home. When it comes to securing home automation, and I've picked on, does anybody have one of these on the top right there? It's an IoT dog food feeder. I think it's fantastic. I don't have one, but I really want one now that I found that image. There are a number of products that you can buy off the shelf, including Sonos speakers, which I got one for Christmas. I'll revisit that thought later on in the talk, because for those of you who know anything about Sonos products, you're probably wondering why a privacy freak has a Sonos speaker. We'll come back to that. But basically, when we're looking at securing your home automation, we're looking at securing the devices that you put into your network. That's one of the biggest issues we have. The main problem is that pretty much all of these devices will connect off to the cloud. There is some intra-network communication that can happen, like your mobile phone can talk to LifeX or a Hue bulb via the local network, but they also connect to the cloud to provide extra conveniences. They connect to a software as a service type provider to give you the ability to automate things. That provider can talk to your systems and make lights come on automatically based on certain rules. It's also able to observe what's going on in your house. And we all love quantified insert stuff here, quantified self, quantified web. Quantified IoT allows you to monitor what's going on and perhaps learn from the way your house is being used to do things like maybe make your automation a bit smarter, or maybe you've identified some way that you can save money. I was talking to somebody who's been looking at data coming back from smart meters a couple of days ago, and they found that some of the data was showing that people were putting heaters on an hour earlier than they needed to, and this data that only the smart meter company or the energy companies have access to at the moment in order to analyze this, they could actually save all of their customers money by saying, start your heating at 5 instead of 4. So there's all this observable information that we can get out, and software as a service providers provide that as a layer over the top. It's all very convenient. We love the convenience. And then there's the control. Control when you're not at home. How do you turn on the lights when you're not at home? I'm not sure why you'd want to. How do you turn on the air conditioning when you're leaving the office because you know it's a hot day, you've left work a little early, therefore the timer's going to turn it on too late and you're going to swelter as soon as you come in? So there are reasons why they connect to the internet, to these external services. But it's a black box. I mean, not just because I chose a server that looks like a black box, but we don't know what's going on in there. So a couple of issues that came up. I don't know whether any of you are familiar with these three particular issues. Amazon Key. Who's familiar with Amazon Key? It's a lot more popular in the US. A couple of hands up. Basically, Amazon were having issues, or rather, people having Amazon deliveries were having issues with their packages being stolen. I don't want to say popular, common. It's more prevalent in the US, or at least you hear about it in the US, where people drive down streets. Has anybody seen the videos where people put out trick parcels and they're filled full of glitter? Yeah. So it's like, you can build that to really piss off somebody who's going to steal something from you. Amazon felt that they probably had a better solution. I'm not picking on Amazon, I'm not picking on Google. There are large companies and small companies that all have issues. But they had two major issues with the way they implemented this facility. So the idea was that an Amazon delivery employee contractor could turn up at your house, open your door and leave the package on the inside, close the door again and walk away. And then when you get home, nobody can steal your package because it's in your house. For added security, you can also get a camera. And the camera, you would sit on a table or something near the front door, pointed towards the front door, connected to your Wi-Fi. And then when the Amazon employee comes along and unlocks the door, they're captured on video, you can see what's happening, you can probably look at it live remotely, and you've got evidence of what happens. So if they come in and leave your package but then steal your cat, then you've got documented proof of this. I love cats. The problem was that the way the camera worked is it would take a photo every now and then. It wasn't actually a live feed. It was a near live set of photos that got streamed to, I don't know, an FTP server, for example. And you on your device, or historically afterwards, would be able to look at the images that were sent there and see what had happened. Now, the problem is that it was connected via Wi-Fi. What happens when you've got a camera connected via Wi-Fi and you start a Wi-Fi jammer? The camera drops offline. So it's a theoretical thing. You'd have to be one of the delivery people to be able to make use of this attack vector. The likelihood is you're not going to do this because you want to keep your job. But theoretically, you could come along, open the door, put the package inside, close the door. Now, you had to lock the door specifically by pressing a button on the device that you had. So you wouldn't do that yet. You would start up your Wi-Fi jammer, knock the camera offline, open the door, then steal the cat, close the door, lock the door, walk away. Then there's no photographic evidence of you having stolen the cat. Poor cat. So they fixed that. The main issue behind that was that the FTP server was only storing the latest image, and when you looked at your device, it showed you the latest image, even if it was 25 minutes old. That wasn't ideal. So they fixed that one way or another. So that was about 6 months after they launched the key. 3 to 6 months later, there was another issue. Imagine, and this is something that an attacker who's not the delivery person can use. You've got a little box, and inside you walk up to the door and you kind of leave it, you hide it somewhere. It's inside a lamp, or maybe it's hidden in a shrubbery. It doesn't need to be very big. And what happens is it's got a Bluetooth frequency scanner inside it, and it's also got a Bluetooth jammer. So the way the door got unlocked is the device would connect via Bluetooth to the door, send a code that had been sent via the internet from this cloud service somewhere, send the code to the door would then verify that the code was valid, unlock the door. And then you'd make another Bluetooth connection to lock the door again afterwards by pressing the lock button. So here's how the process worked. Person comes along, sticks this box that's not noticeable. And even if it is noticeable, the delivery driver doesn't know what boxes you have around your front door. So they're not going to notice anything out of the ordinary. They come along, they activate their device, they get a code, they send it to your door via Bluetooth. The box detects the Bluetooth signal. It can't read it because it is secure, but it detects a signal. Then it instigates the Bluetooth jammer. Delivery person opens the door, puts the package inside, closes the door, presses the lock button. But of course, the Bluetooth frequency is being jammed, so the door never gets the signal. As developers, if you had a device that had a lock button, and somebody pressed on the lock button, and the request timed out, what do you think is a good user experience? Show of hands. Would you say that having a message saying, unable to connect to door would be good? Only 50%. I'll have a chat with the rest of you later. What about success? Yes, so Amazon opted for the second. I'm not going to go too much into detail on the Nest, but you've probably heard the stories where people were able to use brute force attacks or password lists to be able to log into people's Nest account, and then at that point you've got full access to the cameras and the microphones that are inside their house. So there are big security oversights, but they happen with big companies as well as small companies. And again, this isn't an attack on any of the companies mentioned here. We all make mistakes. And I was thinking to myself, there's got to be a better way of doing this. So I thought, let's kind of pare everything back. Let's evaluate what's going on in the different environments. And there's two areas we need to look. First of all, what's going on outside of your house. So the way, we're going to have a look at the aircon example. The way it works, if you want to leave your office a little early and send a message to your home to say, turn the aircon on, or turn it on at this time, you'll have something like a Bluetooth, an infrared blaster, because most aircons aren't enabled yet. So you can send a signal to the aircon saying, turn on. We need to get that message there somehow. So you're going to use your mobile device. And you'll have an app or a website or something to be able to do that. Now, because most houses don't have their firewall open so that there's full access in, hands up if you've got full access into your house. No routing blocks at all, almost like you're a public service. Yeah, 3 people out of 120-ish seats. Most people will, especially the average home user, will have a router and Wi-Fi and everything built in that blocks any requests from coming in. It's a good thing. There are obviously uses. I'm not saying you shouldn't. There are uses for opening it up completely. But in most cases, you're not going to be able to connect your phone directly to your home automation system. So you're going to send it off to this black box somewhere. And the black box is going to take the configuration that you want your aircon to be set to and store it in a database. And then at some point, the infrared blaster, or possibly some other device in between the infrared blaster and the service, is going to make a request to say, do I have any new configuration commands? And it'll then pull the configuration command out of the database and return it back to, eventually, the IR blaster, which is then going to be able to take that configuration and send it via that slightly more dotted line, which is obviously infrared. Obviously. I should have made it red. I should have made it infrared. And turn the air conditioner on. That's all very cool. The problem is that if there's any security vulnerability on the software as a service layer, then anybody can log in. A sufficiently knowledgeable person or persistent attacker can log in and send arbitrary commands to the database configurations, which then your infrared blaster will pull down and run without question because they've been added into your user account area. Here's the next configuration rule for Ben's home. Even easier than an attacker getting in is an employee. An employee could just probably write something directly into the database. And if an employee, who here has not heard about AA Bill? If an employee can insert data in, anybody can insert data with sufficient pressure. If a government employee comes up, that's not necessarily all government employees, if an intelligence agency sends somebody around in a suit and tie and persuades you to set Ben's home temperature to 42 degrees, but you're thinking to yourself, what's the problem with setting your temperature to 42 degrees? Everything that's going to let somebody into my house, I'm going to lock down. I'm not going to put my door connected to the internet. Say, for example, you've got windows, and they open automatically if it's cooler outside than inside and it's a lot hotter in your house than you would like it to be. I think you can see where I'm going here. I don't need to control your windows. I need to control your air temperature. So suddenly I can open your windows, even though there's no way of controlling them from outside. So there are a lot of follow-on effects that can happen. If you can control one item in your house, there are potentially initially unnoticeable effects that could happen out of that. So one way we could do it is we can encrypt all the data. We could have end-to-end encryption, so when you set your configuration on the mobile phone has some key that allows it to encrypt it. So all the way through, it's always encrypted, and only something within your network can decrypt it. So now suddenly, all of these bad actors aren't able to insert data in. But we're now losing the ability to do the observation side of the software as a service. Perhaps this is okay for temperature, but perhaps you want your software as a service provider to be able to say, well, we've been monitoring what your actual temperature was and how you've set it, and we can use AI to learn things and tell you things. They can't do that when it's encrypted. So another thing we could do is sign the data instead. You can generate the configuration. You could do that as like a JSON payload and put the whole thing into a JSON web token. Send that through and store it. It now means that technically anybody can still insert information in. Your hackers and your employees can still put information in, but once it gets to the IR blaster at the end, it's going to verify that signature and determine whether or not it's actually going to trust the information in the payload. So you could say set it to 41 degrees, and the blaster's going to say, I don't know who you are, or rather, you don't seem to have permission to tell me what to do, and ignore it. And we could do a mix between those as well, if you wanted. So a JSON web what now? Who's not familiar with JSON web tokens? About 5%. I'll quickly go through what they are. They're essentially really convenient packaged bits of information that gives you either an identity or an assurance that somebody has access to a service. So there are three components. We've got the red part, which is the header, the purple part, which is the payload, and the green part, which is the signature. The header will tell you what kind of hashing algorithm is used to sign the entire bundle. HS is the HMAC 256, SHA-256. There's also RS-256, which is RSA, so that'll be public-private asynchronous signing, whereas HS is a pre-shared key. Certain pros and cons for either of those. There's a whole lot of others as well, but those are the predominant ones that you see. And then it tells you the type. So the type of this JSON Web Token is JSON Web Token, which I only know because I assumed it was a JSON Web Token. So I'm not sure why we're telling people it's a JSON Web. I'm wondering whether there's going to be a JSON Web Token version 2, but at the moment I'm not sure why we put the type in there. If I didn't assume it was a JSON Web Token, I would never know. Then we've got the body, the payload, and that's where we get information like the subject of the person who's logged in, job title. So this is the kind of token you'd see that describes somebody's identity, often used in web applications. You would use a similar kind of mechanism, but instead of putting somebody's identity in there, you'd put the configuration in. The target is the aircon, the value is 41, and the mode is heat, or cool. And then to generate the signature, we basically base64 URL encode the header and the payload, run it through the hashing algorithm. Now, the beauty of this is that the signature is basically self-validating. You don't need to refer. If you've ever used opaque tokens, which are like the UUID-esque looking tokens that you use as a bearer token for talking to an API, once the API receives that token, they need to verify with a third party the token's still valid. JSON Web Token's wrapped up. You can do that without having to talk to the third party. So now that we've had a look at what's on the outside and how we can pass the messages around, let's have a look at the inside of the network. So most people will have something that looks a little bit like this. Possibly less, possibly more, but we'll have things like laptops and printers and the speak to it thingy. There's the Sonos there as well. So the Sonos, my wife bought me a Sonos, which I love. I love the fact that she bought me an internet-connected speaker. Who here has heard about the Sonos issues with like the recycling mode? Yeah, that was a really cool one. Came out we heard about it a few months ago, I think. About half the people put their hand up very quickly. If you want to upgrade your Sonos speaker, Sonos have a mechanism that allows you to do an upgrade at a reduced cost if you put your Sonos into recycling mode. Now, you would probably imagine to yourself, recycling mode is good. Recycling is good. Why wouldn't I do that? So you press the button saying go into recycling mode, and an unstoppable 21-day timer starts that will then brick the device completely. There is no way of undoing it. And even if there was a way of undoing it, if you could reflash it so that it would work again, they blacklist the serial number of that device in their servers so that even if it does connect in the future, it's going to say, nah, sorry, access denied. Great way to recycle. So with a mentality and ethos like that, I have questions about the security of putting a device like that in my network in the first place. So obviously, I want to keep data away from trusted environments. So I'm going to set up VLANs at home. I have a trusted environment. My printer, my phones, my desktops, anything that has access to my file servers, anything that has access to highly sensitive information is going to go into the trusted environment. And I'll have some kind of mechanism for making sure that I know exactly which device goes in there. Maybe I only let it in by a certain MAC address, or I'm running radius so that there's a fixed username and password per device or something. Then I'm going to have an IoT VLAN, and that's where I put everything that, I'm not quite sure what it does, but it probably needs to talk to the internet, but I don't want it talking to my trusted systems. If I have visitors around, I might have a guest VLAN that doesn't have access to anything at all, and security I might want to keep separate as well, because there's even more danger in allowing anybody to see what's going on in your house. And in the case of the IR blaster, perhaps, and definitely the dog food feeder, I might even want to put those into a completely isolated VLAN that don't have any internet access at all. So as an aside number one, and I mentioned this was one of the benefits of the JSON Web Tokens already, once the JSON Web Token enters the isolated VLAN over here, and the Bluetooth, the IR blaster has access to it, it can verify the validity of that without having to connect back to the issuing server. So there's a powerful part of being a JSON Web Token at that point there. The aside number two is about things like the Sonos. I can't actually talk to my Sonos when my phone is in the trusted environment because it uses multicast to request information about Sonos speakers that are in the network. And because multicast is mostly broken, and I don't understand too much about multicast, I'm learning a lot about it at the moment, but there was a talk at the Security and Identity mini-conf a couple of days ago about how most routers have multicast disabled by default. I think maybe I need to investigate that a bit more. I can't actually, like the Sonos never gets my multicast, hey, who's there request. So I'm unable to connect. I have to connect into my IoT VLAN from my phone in order to be able to control my speaker. So I'm losing my convenience there. So what's on the inside? We've got our IoT VLAN, the isolated VLAN, the trusted VLAN. Trusted VLAN can talk to IoT, IoT to isolated, but the reverse is not possible, and isolated has no access to the internet. So this is my dream environment. This is what I'm currently working towards. So we have the mobile device that sends an encrypted payload to the server, which stores it in the database, and then down here I have a Raspberry Pi or something, some kind of computer that polls on occasion to pull the latest configuration in. It'll then take that and decrypt it, because it has the key for decrypting. So the clear text version is never outside of my network or outside of the mobile device. Push that into an MQTT broker of some sort, so that any device on the network can now say, hey, what's the next message? Subscribe to certain channels. So I've got a channel called irrigation/valve, because I'm working on my irrigation system at the moment. Use something like Node-RED, which, if you haven't seen it, I'll do a demo in a second. If you haven't seen it, it's basically a way of drag and drop-ily programming data flows and causing actions to happen. Very useful for defining rules around how IoT should operate in your home automated environment. Node-RED can then talk into the isolated VLAN and send messages to something like Home Assistant or Mozilla's IoT gateway. You could also run those in your IoT VLAN, and there are certain advantages you'd get out of that. I won't go into that just now, or in this talk, but ask me about it later if you want. But it's useful to have something inside here, a single API endpoint that Node-RED could talk to, and then something like Mozilla IoT Gateway can talk to your LifeX bulbs, because it already has that mechanism built in. So there's from your perspective of setting it up, it makes it more convenient for you. And in there, we then have our IR blaster and the speakers, the light bulb, and Zigbee or Z-Wave communications mechanisms. But these can never talk outside. Whatever you put in there is not going to be able to leak information to anybody outside of your network about anything in any part of your network. So I'm feeling a lot happier where these devices are now. The IoT VLAN is all stuff that I control. Either that or it's open source software that I have a lot more confidence in. Everything else is in an isolated VLAN that, even if there's something rogue on there, is not going to be able to leak information back to their mothership. Right. Any questions about that so far? How am I doing on time?
20 minutes.
20 minutes, good. I think we'll have plenty of time for the demo and then maybe some questions.
25.
25, even better. All right, let's have a look at some code. So I have, can the people at the back of the room see the LEDs? Yeah. Embiggen, I shall definitely embiggen. So I've got an ESP32 here, which is connected to some LEDs, because basically what I'm going to do is control the onboard LED, just for demonstration purposes. And I figured you might not see the onboard LED, so I'll put some more on. So basically, that's just there for you to be able to see flashy lights. That's exciting stuff. And then over here, we have the source code. Can you all read that at the front? Probably not. All right. Bigger. All right, so my SSID and password are not SSID and pass. I recommend those to anybody. All right, so basically, I'll go through this very roughly. If you want us, all this code is in GitHub. You're more than welcome to tear it apart. But essentially, I've taken the sample web server application for ESP32, which I'm programming through the Arduino IDE software here. I'm going to create, so we've got this render function, which is basically a really dirty way. Who loves HTML inside the code? I think web developers have been fighting against that for ages. I don't care. So I just plonked it right in there. It's basically got like a couple of links and stuff, and we'll see the actual rendered output of that in a second or a minute. So we're going to set things up. First of all, I'm going to turn the LED off. I'm going to start the Wi-Fi connection using the SSID and password. I'm going to wait for the status to say, yep, we're connected. And then I'm going to print out what the IP address is, just so that I know how to control my own device. Also, I've got MDNS, so if your router supports it, this means that I can actually just go to irrigation.local and get to the web page. So I've now got essentially a web server running on this tiny thing here. That itself is pretty cool. When I first just took the sample code and deployed it, and it worked, I mean, obviously it would work, but the feeling of joy of being able to connect via HTTP to that thing is kind of cool. All right, and then we've just got so the server provides some very rudimentary routing. I haven't broken it out into functions. I've just put everything in line to make it easy to read. And essentially, we've got an endpoint called LED on. We've got some authentication here. Obviously, you don't want, even though it's within your trusted environment and technically nothing else can connect in, if you've got something rogue in any of the networks, you don't want them to be able to connect to the endpoint and just turn your LEDs on. LEDs probably. You don't want them to unlock your door. So I've put some rudimentary authentication in there. Username and password are both admin. And then we write a 1 to the built-in LED output. So we're turning the LED on. We're remembering that because the renderer is actually going to re-render the page and tell us whether it's on or off, just as a feedback mechanism. We're going to print that out to the serial as well, so we can do some debugging, and then we'll render the page. And then we've got exactly the same thing for off, except it turns it off. Cool? So, oh, look at that. It's already running. Is it running? HTTP server started. So now, if I switch over to, can I find it? Yes. This one, in begin. For those of you who couldn't hear Erin, she just asked me if I wanted some help with CSS. I have some CSS right there. I'm good. The main reason I did this is because I was thinking I was going to be demonstrating on my mobile phone and trying to hit the word on. So I thought, I'll just make that bit big. And then I didn't. So turning the irrigation on, technically, let's try and make sure we can read all the bits. If I click on, we should get... I suppose that's good that it proves the authentication works, right? There we go. LED turned on. Are they on? Yeah. Yay! And off. So it's remarkably simple, and you're probably all there thinking, you know, that's cool, but also it isn't. And I totally understand that, because I evaluate my thought process, and I think most of us have written something as simple as this, like, judging by the average age here, maybe 10 years ago. For me, it's 20. For some of you, it might be 2. But we've all written a really simple page that you click on a link, and it kind of, I don't know, creates a cookie. I mean, that's literally the complexity we've got here. We've got a server that's changing the GPIO pin to true. It's not that exciting. But how cool is it? All right, let's get it slightly more cool. More cooler. Let's bring in this. This is Node-RED. Who here does not know Node-RED? Good few of you. Excellent. So this is really cool. We have a bit of time on our hands still, so I'm happy to take this through relatively slowly. So actually, I spent 2.5 hours this morning, literally this morning, from midnight until 2:30, getting this demo running, because yesterday afternoon it was running on my Raspberry Pi, which then died. But one of the things I like about, so Home Assistant, the little blue square with a white home icon, is basically an open source application that allows you to do a whole lot of automation. It's really, really quite featureful. And you can install it directly onto a Raspberry Pi really easily. It only takes about 20 minutes, including configuration. And then from there, you can click on a link, and you can go to the add-ons, and you can go, I want to install Node-RED, this application here. Or I want to install Mosquito, which is the MQTT broker that we're using. And it installs it onto your Raspberry Pi, and it just works. It's amazing. But my Raspberry Pi died. So at about 4:30 yesterday afternoon, I sent Erin a message, and I said, I'm jack of this. Where are you? Let's go for a drink. So then I got home and I fixed things. So this is actually running on my laptop now. But ideally, when I get home and I manage to fix the Raspberry Pi, or probably just replace it, you can have a single device that's running your Home Assistant software, Node-RED, and Mosquito, and probably other things you need to do as well. And it also has all of the plugins and ability to talk to popular IoT devices like your light bulbs and probably even Sonos. So this would normally be running like inside Home Assistant, but in this case, I'm running it as a standalone application. And what I'm doing is I'm basically emulating at this point here what would happen when messages come in from the public service. So we've got, I don't know whether I can make that bigger. I can. So we've got a payload there, and I'm basically saying the valve that I want to modify is the one for the veggies, and I want the status to be 1. Can you guess what that one does? It turns veggies into, no, it doesn't. We've got one here, which is water the trees, and basically that's the same, except the valve is trees. And because when I first put in this proposal, I thought, wouldn't it be great to have actual irrigation here and spray the front row with water? We've got splash zone, which turns on the splash zone. I think these people right in front of me are very happy that I didn't get to that point. However, next time I give this talk, I will be there, so that's going to be fun. And then I've got one down here, which is all off. Basically, I've put in valve is star. That can actually be anything. And we'll look at why that can be anything in a second. And status is 0. So that then gets passed into this MQTT out node, as they call it, basically broadcast to the MQTT service locally on the topic irrigation valves. For those of you who aren't familiar with MQTT, it uses a pub sub or a publish and subscribe model. So anything that talks MQTT can say, I'm interested in messages that are about the topic irrigation/valves. And then anytime anything gets posted there, it'll automatically get that message because it's subscribed to it. So one device can send a message out about, here's a state change that I want to make to valves, and all the related entities can subscribe to that and use the information if it's related to them. So it's a great way of, it's almost like event-based message passing, almost. So then down here, that's basically my control panel. You don't need that in Node-RED to work, but that's my way of getting information in for testing. So down here, this is where the nuts and bolts happens. This is the MQT input. And it basically says, I want to subscribe to anything that comes in on the irrigation valves topic. I'm just going to make that a little smaller so we can see more. We're going to basically, the green box is the debug. We're just going to dump that out so we can see exactly what came in. At the same time, we're also going to turn off all the valves. So what we're doing here is 43.149, that's the ESP32 down here. So we're basically making a request to /LED/off. So the first thing we want to do whenever we get any message about what irrigation we want on is we're going to make sure the others are off. The main reason for that is not technical. It's because the water pressure is going to be too low if they're all on, and then the water won't come out and the veggies won't get soaked. So I turn them all off first. And then we go through a 1 second delay just to allow the off to happen before the on happens, just to stop that because it's asynchronous. That's not a perfect solution. I was actually hoping that I could chain it onto the turn off all values, but the output from that is no longer the original payload, so then I don't know what to actually do anymore. So I'm still working on making that a bit more reliable. But a 1 second delay hasn't caused me any problems yet. We're taking that string and we're turning it into JSON, because we know we need to interpret it somehow. And then we say, are we opening a valve? This is basically looking in there and saying, is the value of payload status equal to 1? So in the previous example where I said valve star status 0, as soon as we hit this block here, it doesn't matter what's in the valve's value anymore. The status is not 1, therefore it'll stop flow. So I could put in valves is all, or valves is monkey, I don't know. And then we have which valve we want to look at. So there's basically a switch statement. We've got veggies, trees, and splash zone. And finally, we then use an HTTP output here. So for waters and veggies and trees, I didn't actually bring any veggies and trees with me. So I'm only going to debug output that. But down here, if you click on the splash zone one, we're going to turn the LED on. Clear as mud? We'll be at the irrigation game on. All right, so if I click on what are the veggies, let's just go to the, where's my mouse? There it is, to the debug output. We're already there. So if I click on what are the veggies, you'll see a little bit of flashing there. There was a little bit of text that turned on under turn off all valves. I'll click it again so you can see it. And basically that's node red saying I'm making the HTTP request that you asked for. And we can see the information on the right-hand side here. The debug output for water the veggies is shown as well 1 second later. If I want to water the trees, then it says water the trees. That's boring, isn't it? But it gives you an idea of how the flow works of node red. So now let's take it one step further. And you'll notice from my original design where I wanted to be able to pass information through encrypted and then get it to the endpoint, I'm actually working backwards in making this happen. So we've got the ability now to turn the LEDs on and off. Now we've got node red that's able to communicate with it to turn it on and off based on messages that are sent in. Let's try and get a message in here. So because we all love security, and I like my mouse to work. Who needs a mouse? There we go. All right, who's heard of JSONbox? There's also JSONstore.io, very similar thing. It's a public service that you can post anything to and it'll remember it. The only security you have is in that box there, 3BA0344 blah, blah, blah. That's unique for your box. A new one is generated every time you go to the website. That's basically like your API key. Don't share that. Definitely don't put it on the screen when you're giving a presentation that's being streamed to the world. Let's make that a little bigger. So, maybe not that much bigger. Right. So if I run a get on here, the output there is not going to change. Okay, if I refresh the whole page, and I run a get against that, the output is just open square brackets, close square brackets. That's basically saying, for this bucket of information, we have no data for you. If we then come in to node red again, let's grab water the veggies. We'll take this whole JSON string here. We'll paste it in there. And we go to post. And now we have a single item. That's the response. If I hit the get again, it would give me an array with just that one single item in it. So we can now pull that by using that URL from anywhere. Let's do that. Oh, that's not the button I wanted. Which one's the button I wanted? That one. How's that? Good. All right, so in here I've got a few different documents, a few different files. We've got generate key pair and message, which we'll come to in a second for the encryption side. We've got poll. This is the JavaScript we're going to run now to poll for the service. Poll encrypted, which we'll use later, and a public private key. So let's have a look at poll first. Basically what we're doing here is we're making a request to that JSON box, particularly. We're passing in a query string to say limited to 1 and sort by created date. So we're going to get the oldest one first, because obviously we want to process the old one before the next one. So that's going to give us just one single result. With that done, assuming that there is a result, we're going to extract it out of the payload. We're going to delete it from JSONbox because we don't want to process it again. And then we're going to send it to the MQTT broker. That make sense? And when we do that, we're going to stringify the payload because at this point it's JSON again. So if I run node poll.js, but before I run that, we come over to this window here and clear this. So if I poll now, it's going off to the server, and it's pulled that information in. It's de-JSONified it, turned it into whatever, and it says, what are the veggies? That's gone via jsonbox.io. So we're now at that point where we've got the full flow working, but obviously anybody can inject anything in there now. So let's close it off with the encryption. Make you big. There we go. So if we have a quick look at generate key pairs, this is basically using the OpenPGP.js library. And in there, make it a bit bigger, we're basically going in and creating a new key pair with a passphrase super long and hard to guess secret. I took that from the documentation. I can't take credit for the high amount of entropy in that password. We're creating a private and public key, and then we're just writing them out to a file. So I will remove the public key and the private key, and then I'm going to run generate key pair again. And if we look in there, you can see we've got the private key at the bottom and the public key at the top. So we can now use this for creating and verifying messages. So if I run generate message, here's a PGP message that basically says, turn on the splash zone. And if we, let's see, how can we do this? If I use watch, watch is a tool that allows me to run a script every 2 seconds after it ends. I'm going to run node, if I can type, poll encrypted. So it's now every 2 seconds going to pull the latest encrypted payload down, which is not doing anything at the moment. I'm going to clear that, and then I'm going to come to here and see if we can see everything at the same time. Right. So if I paste that in there now via post, then within 2 seconds, our poll should pull that down, decrypt it using the private key that's on the machine. This was just encrypted using the public key. And then send it via MQTT. And hopefully those lights are off at the moment. Yes. If this doesn't work, my life's at an end. You know what? I hit enter. I didn't click go. Let's try that again. That's the demo in a nutshell. One thing I love about OpenOffice, no, there isn't anything. Oh, it's open source. There is that. Is when you switch away and you go back, it actually, sometimes it goes right to the front. So one thing that I wanted to really try and share with you, not just my story, but the thought process that went into how can we secure this information. So this code is all, I haven't actually put the URL on there, but if you go to github.com/Ben-Dechrai, you'll see one up there called demo-irrigation. Feel free to pull that down. It's up to date at the moment, I think. Have a look through that code if you want to steal it and use it in whatever way you want. But have a think, when you're developing software where data is being passed around, have a think about how you can secure it in ways that still allow you as a business or a product supplier to do what you need to do with that data, but enhance the security. Don't be a Sonos. Be a, I don't know, Node-RED. Thank you. I think I have 1 minute. Is that including questions? Time's up. Well, in which case, I'm going to steal 2 minutes of your break time to talk to you very quickly about a new thing that I've just created. I don't have permission to talk about this, but it's not a business as such. I travel a lot, and I hate the fact that there are obviously climate implications for that. One of the things I've been doing for many years now is at the end of a year is I'll work out roughly how much CO2 I've probably emitted into the environment through having flown, and I will invest in tree planting to offset that. It surprised me 2-3 weeks ago to find out that tree planting is one of the worst ways of offsetting CO2 emissions. So I spent a while trying to investigate what was actually good, and it turns out there are lots of good ways of doing it, and nobody's really certain about how to measure which one's better and which one isn't. And also because there are so many, and there's minimum investments to do something. Like if you wanted to fund rocket stoves in a third world country, there's a minimum amount you need to donate, and there's only so many things that I can support with my money, I thought, wouldn't it be good if everybody who wanted to do this, but couldn't be asked looking into what was the best way of putting their money into addressing climate change, ways of reducing CO2. Wouldn't it be good if there was a service that did that for you? Couldn't find one. So I've created Hoist. Hoist.earth is the domain. If you go there, at the moment, all it is a MailChimp sign-up form for a mailing list, because it literally is only about 5 days old as a concept. But my proposal is that if we can all put our money together, then using the mindset of people to find out where the best place is to, so that there'll be like public contributions as well to ideas of where to invest it. I'll manage it just mainly because you need somebody to focus things. But then we can use that money to, as a big bucket to support lots of causes that are the best way currently of supporting programs that address climate change. So if you're interested at all, come and have a chat with me afterwards, hoist.earth. Also, come talk to me during the break about everything that I've just spoken about at home automation and whatever. Thank you for your time. Sorry for taking an extra 2 minutes.